A black hole discovered by NASA has given astronomers a glimpse into just how enormous these mysterious objects can get. So just how big was the black hole that had NASA experts spinning over its massive size? Should we be worried about any black holes swallowing up our planet anytime soon? Well, we will find out in just a second. Before that, please subscribe to Futurephile to watch more fascinating videos on futuristic tech. Black holes are dense objects in space with such a strong gravitational pull and a seemingly bottomless pit. These objects are shrouded in so much mystery that even though we know how they work, much of the physics behind black holes remain a mystery. It would be too dangerous to ever actually go into a black hole unless you wanted to be squashed into an astro spaghetti. Black holes are some of the largest objects in the observable universe. It can be a bit intimidating to think about just how large these galactic giants can grow to be. It's an even more intimidating mystery to understand what just might lie inside these black holes. If you want to know about black holes, you have to understand gravity, so that's where we are going to start. Gravity is a universal force that can push or pull things away from you, depending on the mass of the object. Our sun is a huge, dense object that has a massive gravitational pull. This is why Earth, along with every other object in the solar system, can revolve around it. When talking about the density and gravitational pull of black holes, scientists equate the gravitational weight of the sun to equal one solar mass. Remember that for later. There is plenty of evidence to suggest that some of the earliest black holes discovered are actually way bigger than originally thought. The very first black hole that was ever observed was Cygnus X1, located within the Milky Way in the constellation of Cygnus. An eerie, dark glowing picture, the image we have of the very first black hole is actually of the glowing gas that swirls at the edge of a menacing shadow. It sits just at the threshold it takes for a black hole to exist at 21.1 solar masses, relatively tame compared to the black holes we're going to get to later in this video. So just how big can a black hole get? One of the biggest holes in documented history was discovered by NASA, which expanded the way astronomers assumed about how black holes work. To create a black hole, you must have the right conditions. You need a great amount of mass and a great amount of density. The environment would need to sort of be similar to a pressure cooker. Imagine taking our solar system sun and squashing it down to a size just 2 miles in width. The pressure from that would be enough for our sun to collapse in itself and become a black hole. However, most black holes of this small are merely hypothetical. The smallest black holes known in the universe are referred to as primordial black holes. Nobody knows if these black holes exist, but if they did, they would have to be some of the oldest objects in the universe. They would likely have been created just shortly after the Big Bang, some 13.7 billion years ago. But primordial black holes are so minuscule compared to their Goliath peers, they're almost not worth talking about. We only know they might exist because of special infrared technology that picks up on these primordial black holes that have been detected to be as small as a single photon. Most black holes in existence are far larger than these primordial black holes and rely on much more to stay alive. To keep their massive size and epic universal journey through space going, black holes stay alive by gobbling down on the gas and the stars they encounter in their paths through space. This then begs the question, is Earth safe from the wide mouth of a black hole? The short answer to that is yes, although astronomers discover black holes located closer to Earth, hiding in plain sight. But no worries, if we've made it this far, it's likely that we'll be safe for at least the remainder of our lifetimes. Black holes have the power to devour our entire solar system, but the ones that are big enough to do it are way too far from Earth to ever catch up to us. The black holes that we know exist for a fact and can be observed are broken up into categories based on size. Sizes can range from primordial to stellar, intermediate, and supermassive. The smallest observable black hole in the universe is measured at 6.3 solar masses and just 15 miles across. But don't let its size fool you. Researchers have discovered that these teensy black holes have a stronger tidal pull to their much bigger counterparts. Stellar black holes are the most well-understood category of a black hole. These black holes come into existence in the aftermath of a star's death. Typically, we associate the death of a star with a supernova. a massive outward explosion of gas and matter that looks like beautiful, colorful cosmic fireworks. Well, these beautiful occurrences are reserved only for stars that have a mass of 20 solar masses or lighter. Anything heavier than that, the star will implode on itself when its time has come. The more matter that you throw at it, the larger the black hole will grow in size. The mass and pressure these events need to create stellar black holes yield holes that can grow to well over 100 solar masses. Hiking up the scale of black holes, the category of intermediate black holes is exactly what it sounds like. These holes are not entirely small, but not impressively massive either, just somewhere in the middle. Intermediate black holes are thought to occur when multiple stellar mass black holes collide with one another. This collision doesn't happen like in one swift bang. The two stellar black holes do a kind of cosmic dance with one another for a while before finally merging. As their gravitational pulls act as a magnet, pushing and pulling the holes to and from one another, the gravitational masses finally merge, creating one huge black hole. The massive two 1-ounce 100 solar mass black holes combine to create a hole with a density of over 1 million solar masses. Can black holes get any bigger than a few million solar masses? Yes, much bigger. Try a few billion solar masses. Supermassive black holes rarely hold back anything when it comes to devouring everything in its path. All supermassive black holes have a history of taking in a great amount of material or merging with black hole after black hole to grow to its enormous size. Some scientists have tried to see if there is any way to observe a black hole in more detail to tell just exactly which method it took to form, but black holes have something called an event horizon. The people at NASA describe the event horizon as a boundary where anything that passes through is trapped within the black hole. So, it's rather impossible to tell just what method a black hole took to reach its supermassive size. Black holes are extremely dense and therefore have a tendency to hang out by the center of galaxies, where there tends to be some of the densest energy that isn't a bottomless shadow. Welcome to Home 15A Galaxy. This galaxy is an example of an occurrence that has been recorded multiple times throughout the universe. This galaxy is home to a black hole with a mass that is 40 billion times the size of our Sun. That is the size of more than half of the stars in our galaxy combined. A black hole that massive could comfortably fit the size of our entire solar system in its gaping hole. It wasn't too long ago that a black hole was discovered with a density of over 66 billion solar masses, which is larger than every star in the Milky Way galaxy combined. This monstrosity of a black hole is known as Ton 618. How do you even discover a black mass that big in empty, pitch-black space? Well, believe it or not, black holes can be illuminated with the help of quasars, the brightest object in the universe. Quasars are objects from the early universe that are powered by supermassive black holes, much like Ton 618. As far as we know, Ton 618 is the most massive black hole in the observable universe, with a diameter of over 242.2 billion miles. The massive black hole is located very far away from the Earth, 10.4 billion light-years away to be exact. The light it emits from its quasar has a long journey of more than 10 billion years to reach the surface of our planet. So with that information, we can only observe Ton 618 from when it was in a much more infant state. The black hole we know to be the biggest in the observable universe can't be more than 3 billion years old, meaning it's one of the oldest objects in the sky. Who knows how large the black hole could reach in the next million or even billion years, that is, if humanity is still around to observe it. There are only two possible ways that Ton 618 could have formed. It was either that the black hole has been consuming hordes of space matter for billions of years, or it's the result of a long line of merging with other black holes. We may never truly know. There's a lot we may never know about our universe, but we can try our hardest to reveal its secrets. If you like this video, you may also enjoy this next video that is shown in the end screen. See you there.